Do you know if the traitors are playing an excellent game or if they're just making a mess mathematically? The ultimate goal of the traitors is to be in and amongst the last people standing, since that gives their team a near guaranteed win. We'll talk about the real win conditions in a later video. In a game built around social deception, the best strategy is to increase the confusion and keep the faithfuls guessing on what they can and can't trust. In information theory terms, the uncertainty around a given probability is called its entropy, or Shannon entropy, named after Claude Shannon. Let's take a simple example. A balanced coin is going to have 50% chance of landing heads and 50% chance of landing tails. If instead I told you that it was a weighted coin that landed heads 99% of the time, you'd be very surprised if it landed tails, since you would have been pretty certain of the outcome being heads. And if I was telling the truth, which I am, the odds are that it would have landed heads and we would have been correct in our certainty. So uncertainty can be related to how much additional information do I need to know the outcome. We'd want to actually toss the coin to see the answer for a balanced coin, but we'd take it as nearly known that it would be heads in the second case. We'd want less information to be informed. So the more confident we are in an outcome, the less information we need to uncover it. This gets plotted like information needed for a given probability of a given event looking like a negative log graph. And this works when it's an either-or situation. You have two options. But when there are multiple possible outcomes, say 22 possible players being a traitor, we take the weighted average over the possible outcomes of how much information we need in order to be certain in the answer. So that is the total uncertainty in the system, the total entropy. And this is the equation for it. So the traitor's job is to keep the expected surprise high. At the start of the game, the probability is evenly spread across all players. This is the highest entropy state of the game. But as the group focuses down on a single player, it lowers the entropy in the game, leading to faithfuls successfully banishing someone, hopefully in their case a traitor. So the traitors have to keep the faithfuls guessing. But if you try and increase entropy by throwing too much suspicion on one person, you instead draw suspicion towards yourself, and ultimately pull the certainty in a direction, just the wrong one. And that's exactly what happened to Fiona. So are the traitors playing a good game? That's yet to be seen, but Fiona definitely wasn't thinking mathematically, that's for sure.